Hi everyone, this is Mingi Kwon. I'm going to introduce the paper Training-Free Content Injection using H-space in diffusion models. Diffusion models is one of the most important generative model, which shows remarkable performance in image generation. We can generate very high quality images with diffusion models. We introduced a method, inject fusion, which injects the content of one image into another image using diffusion model without any training. With given image, we extract the content information from that image and inject it into other original images. Here's the background. Recently, Jaeseok discovered a hidden latent space of pre-trained diffusion models located at the bottleneck of the unit named H-space. In that paper, they show shifting the latent feature map along certain direction enables semantic attribute changes. As you can see, if we add smiling direction inside the H-space, then we can make a person smile. However, its application is limited to changing certain attributes, and also it does not provide as explicit operations as in GANs. For example, replacing feature maps. This means they only add certain directions to edit the images, like this. Then what happens if we replace the whole H? If we extract H's from two images and replace one as the another one, then what's the result? Here's the result. We observe the replacement has very low quality, but also we can observe the H has the content information. The main content is specified the H, injected H, and the other aspect comes from the other component. Example, features in the skip connections. So, we find this injected image has a content. Henceforth, we named it as a H content. However, as you can see, the replacement caused several distortion in the images. Why it happens? We are focusing on there is a skip connections inside the diffusion model. We observe H is highly correlated with the matching skip connection. And if we simply replace the H, the relationship is broken. So here's our first attempt, adding 2H, which increases the correlation, and the result looks better, but still has some artifacts. So we introduce spherical interpolation inside the H space, which ensures the constant correlation. Here's the result. If we use StyleCLIP, the quality is improved, and it exhibits fewer artifacts and better content preservation. Here's another question. If the problem involves the relationship between H and skip connection, is there any way to directly modify xt, which is the latent variable of diffusion models? So we propose the method latent calibration. First, as I explained, we inject the content as xt to xt-1, which is the reverse process with StyleCLIP. Second, we solve the DDIM equation with following equations. About this equation, please refer to paper for details. In this equation, there is a hyperparameter omega, which adjusts how much of the content will be injected, or how much original information will be preserved. When we increase omega equals 1, the original image is preserved. And when we use omega equals 0, the edited images looks like the same as in content injected with slurp. Finally, we step through a reverse process. In that time, we only use DDIM reverse process, which is a pure diffusion reverse process. Here's the result. When we use calibration, the result looks better, and while preserving content elements. And this latent calibration can be adapted for any feature adjusting method. We directly get XT, which involves the edited things without any adjusting inside the feature maps. We also provide hyperparameters with FID score and ID score and style loss in StyleCLIP dataset. When we conduct the slurp, there is a ratio of how much content will be injected, the gamma. We found gamma equals 0.6 is sweet spot. How much interval we will add contact information is one of the important hyperparameter. We found only 400 time step is enough. When we use latent calibration, there is a hyperparameter omega, which means how much information will be remained. We found omega equals 0.3 is sweet spot. Here's some result. Our inject fusion can be adapted with various datasets such as AFHQ-DOC, Metfaces, and also our method can be used with artistic references. And because the H space has spatial dimensions, we can inject content information in specific area, which enables local mixing. So our inject fusion can inject content into another image in various style, various content images. Thank you.